Keep it up. That's good. Very good. Good, all right. Mr. Chairman, I've selected the 5 players. They'll make up the team for the semifinals. The selection was based on their form and training.
That's great, and thanks a lot. I hope we can do well in the semifinals. Maybe you can give me a rundown of your selection, so I can get to know the player.
Sure, no problem. There, number 7. His name's John. He's 178 centimeters tall. He's very good at long-range shots. He'll be playing left point guard. See number 10 there? That's Tom. He's 181 centimeters tall. He's very good at counterattacking. He'll be playing right point guard. Number 6 over there is Sam. He's 191 centimeters tall. He's very powerful under the ring. He'll be playing center. Number 8 there is Paul. He's 182 centimeters tall. He's very good at shooting from the baseline. He'll be playing left side forward. Next is Mark, number 15. He's 178 centimeters tall. He's really good at getting in close. He'll be playing right side forward.
Seems the players are in good shape and very skillful. I'm sure they'll put on a good show. Oh yes, who's going to be the captain?
I haven't decided that yet. I'd like to talk to you about it.
A team captain represents the whole team. We have to choose someone whose character reflects the team's characteristics.
Well, one factor is height. It has a crucial impact on the outcome of the competition. I was thinking we could just take the average height of all the players, then select the player whose height was closest to the average. The average height equals the sum of the players' heights divided by the number of players. In this case, 910 centimeters divided by 5 equals 182 centimeters. Paul is exactly 182 centimeters in height, so he'll be the captain.
You use the sum of all the data divided by the number of data to obtain the average. Now then, this is just one of the averages of a set of statistical data. It's called a mean. The mean of heights, the mean height equals the sum of the players' heights divided by the total number of players. However, I have another suggestion. We can also consider the median of the players' heights as a reference for the team's characteristic. When a set of data is arranged in either ascending or descending order, the middle value is the median of the set. So, if we line up the players from the shortest to the tallest, the height of the middle player is the median of their heights. In this case, 181 centimeters.
Tom will be the captain.
But wait, then again, there's a third possibility. We can take the mode of players' heights as a reference for the characteristic. In a set of data, the value that occurs most frequently is the mode of the set. Therefore, the mode of the players' heights is 178 centimeters, which means that either John or Mark could be the captain.
What is the most suitable factor to reflect a team's characteristic?
Well, the three methods concerned, that is to say the mean, the median, and the mode, all express averages of a set of data. They're all used to express some specific characteristics of a set of data. This can be the average value of the whole set, the value at the middle position, or the value that occurs most commonly. They are used to measure the center of a set of data. They're measures of the central tendency.
Well, who should be the captain?
Choosing a captain concerns the whole team. It should be discussed with all the members. They could even take a vote on it.
Yeah, good idea. All right, everybody.
Gather around, guys!
That was really good.
Yeah, good thing, right.
Yeah, I couldn't get the shot off, though.
The bill for the snack comes to $80. If we share it equally, 80 divided by 5, that's $16 each.
Right. What you calculated was the mean.
Ooh, Mr. Statistics, I can see why you have no trouble finding a job.
Hey, guys, with this unemployment rate, it's not easy to find a job. I was just lucky. I'm a statistician with a market research company.
Well, if it's not a big secret, how much are you earning?
Oh, it's $9,200 a month, and in this industry, $9,200 is the median salary.
Then how do you work out the median?
Sam, that's not difficult. To find the median of a set of data, you must arrange the data by size. Take this set of 9 data, for example. If they're arranged in ascending or descending order, the datum located in the middle is 60. Therefore, the median of this set of data is 60.
When it's an odd number of data, it's obvious which datum is in the middle. However, if it's an even number, then there won't be a middle value. How can we find the median?
Well, in the case of an even number, we take the mean of the middle 2 data and we use that as the median. Let's take this set of 10 data. The middle values here are 60 and 70. Their mean is 60 plus 70 divided by 2, which equals 65. Therefore, the median of this data set is 65. So the median of a set needn't be a datum present in the set.
The median is commonly used to express an average for salaries. The Hong Kong Census and Statistics Department uses medians to represent average incomes. If we use the mean to calculate the average of our salaries, then we obtain an average for the 5 of us of $11,000. But Paul's been working longer than the rest of us, and his salary is far more than $10,000, whereas the rest of us earn below $10,000. So in this case, the mean is not a suitable way to represent the average of the set of data. On the other hand, let's arrange the data from the smallest to largest. If we arrange the salaries in this way, $9,200 falls in the middle. Here, the median of $9,200 and not the mean of $11,000 is a more suitable way to express the central tendency. As you can see, the median can be used to represent our average salary.
In some cases, we can use another kind of average to express the central tendency. Last time I went to buy some shoes, I asked the shop owner about the shoe sizes.
They look good on you.
They do.
Are they comfortable?
Tell me, how do you decide which sizes of shoe to keep in stock in your shop?
Oh, well, I use the mode of the shoe sizes that were sold in the past. The mode tells me which sizes are the most popular. It's the most suitable way to express the central tendency of sizes.
Wow, the shop owner knows his business, huh?
Yeah, now let me give you a problem to think about. Given this set of data, 1, 2, 2, 4, 5, 6, 7, 9, 9, 10, can you calculate the mean, the median, and the mode? Let's try it. Also, if each item of data is increased by 10, calculate the mean, the median, and the mode. It's not too hard. What if we multiply each one by 5? Can you calculate the mean, the median, and the mode? Good luck, everyone. I hope you all noticed how the measures of central tendency change with the changes in the data.
Hey, it's time we started practicing. What are you reading?
A company survey on the services provided by mobile phone company. We collected the comments from 25 mobile users.
It's not very organized, so tell me, how are you going to organize and analyze the data?
As many of them are repeated, I'm going to organize the data using a frequency distribution table. The first column in the table, denoted by an X, is for the scores. The second records the tallies, and the third, denoted by an F, is for the frequency. The frequency of each score is counted, and the total frequency gives the total number of data. This column, X times F, is used to multiply the score by its frequency and give a total for the respective scores. Therefore, the total of this column gives the sum of all data, in other words, the overall score. The mean equals the sum of all data divided by the number of data. Therefore, the mean score equals the overall score divided by the total frequency, or 64 divided by 25, which equals 2.56.
You're right. When data's put in a frequency distribution table, we don't have to bother with putting it into sequence. So then, how do we get a median from a frequency distribution table?
Oh, well, the middle position of the 25 numbers is the 13th. 3 plus 10 equals 13. So the 13th number falls on the score of 2. Therefore, the median here is 2.
In a frequency distribution table, we can easily see which is the largest frequency. The corresponding value becomes the mode. The mode here is a score of 2.
Hey guys, I also have a statistical problem for you. In this frequency distribution table, a grouping method is used to record the time of runners in the 100-meter race. How can you calculate the mean time for the runners?
First, we take the mean time of each class, X, and use it to represent the time of each runner in that class. Then we multiply the class mark of each class by its corresponding frequency to obtain the total time of the runners in that class. The sum of this column gives us the overall time of all the runners. So the mean time of the runners equals the total time divided by the number of runners, which gives us 14.48 seconds.
Oh, I get it. I suppose as the grouping method can't show each of the runners' times exactly, we use the class mark to represent the average time for each runner of that class. Therefore, the mean time that we calculated is an approximation. So then, how do we find the median?
We can use a cumulative frequency curve.
All right. I think I know how to draw a cumulative frequency curve. We use the frequency distribution table to construct a cumulative frequency distribution table. The horizontal axis represents time, and the vertical represents cumulative frequency. We join all the points with a smooth curve to form a cumulative frequency curve.
In this cumulative frequency curve, this vertex gives the total frequency, which is the total number of data, 50. For simplicity, half of the total number of data, that is 50 divided by 2 or 25, is taken as the middle position. Therefore, the cumulative frequency of 25 gives a corresponding time of 14.3 seconds, which is the median of the runner's time.
But what about the mode, huh?
Oh, when the grouping method's used in a frequency distribution table, the class with the largest frequency, this class here, is the modal class.
But in this example, there isn't much difference between the mean, the median, and the mode, is there?
Hey, we're gonna be late.
All right.
Oh, they'll be here in a minute. Oh, look. Hey, took your time, didn't you? The chairman is here to see how we're doing. Don't let him down, okay?
Where did you get to? We were waiting.
Oh, I've got a job in statistics. We were discussing the various forms of averages.
Averages? As it happens, our club chairman here was a statistician. In fact, he's told me all about averages. He can answer any questions.
Well, I don't know it all. There's room to learn.
All right. Well, sir, among the three averages, that is mean, median, and mode, which method is most commonly used?
There's no fixed rule. It depends on the nature of the data, also the objectives of the analysis. Generally speaking, I'd say the mean is most commonly used. Let's see. We can take a classic example. How to calculate an average income. Of course, if we really wanted to, we could just use a mean for this. But if among the data there are varying values, the mean won't reflect the whole picture. In such situations, it's more appropriate to use the median. That's why, in any general survey on incomes, the median is usually used to reflect the average income of employees.
But what about the mode?
Let me ask you, in families in Hong Kong, what's the average size of a family?
I believe it's around 4. 2 kids are quite enough.
Right, and that number is the mode. As the range of numbers we're talking about is very narrow, it's more suitable to use the mode to represent central tendency. In the recent census campaign, the modal class of the numbers of members in a family was a class between 3 and 4. And in fact, we usually use all the different types of averages together to obtain a more complete representation of the statistical data. Let me give you an example. This chart contains information on the salaries of the employees in a basketball club. The club chairman calculates that the employee's average income is $11,280. He considers it's high enough. Therefore, he decides to freeze their salary. However, the staff representative calculates that the average income is only $8,000, and he asks the boss for a salary increase. Do you know which type of average each is using as a reference to calculate the salary adjustment? Which type of average do you think would most reasonably reflect the central tendency of the employees' salaries, and why?
Yes, that's an interesting problem.
I'll let you think it over.
So, by the way, could I have a salary increase?
Yeah, me too.
Well, we'll have to see. It depends on the results. Let's work hard, okay? And we'll talk about it later.
All right, come on, lads, let's go.
Okay.
Pass the ball.
Yeah, over. Oh.